imagine this. You're on a jury, right?
Hmm.
And you're listening really intently to this powerful eyewitness. Their story is just so clear, vivid, incredibly compelling. You feel like you know exactly what went down. But then this tiny, almost overlooked piece of physical evidence comes up, and it tells a totally different story. So which one do you trust? Which one gets you closer to the objective truth?
That's the classic courtroom dilemma, isn't it? That real tension between what feels right, what connects emotionally, and what actually holds up under objective scrutiny.
Exactly. That tension is so real. And it's precisely why forensic evidence is such a great topic for our deep dive today. We really want to cut through the noise, give you a kind of shortcut to understanding the true value and maybe the surprising limits of different kinds of evidence. So everything from, human memory to some really cutting-edge science, we'll go through the material you shared and try to figure out what really provides objective truth versus what just feels compelling. Our mission here is to equip you with the insights to spot those aha moments, where science meets the scales of justice.
And that initial contrast you mentioned really sets the stage perfectly. You've got the human element on one side, the witness, their memory, it's all subjective, filtered through perception.
Right.
And on the other side, the tangible world, physical evidence, often irrefutable. It's really the difference between someone's narrative and a scientific finding.
So let's dig into that human element first, eyewitness testimony. It's such a big part of our justice system, and well, on the surface, it seems incredibly powerful in court.
Oh, absolutely. A jury can really connect with someone telling their story, what they saw. It's visceral.
But the research you've shared, it shows its actual probative value, its worth in proving something, is often, overestimated.
Yeah, and the really deep insight isn't just that memory is flawed. It's that it's an active, ongoing reconstruction. Every single time you recall something, you're not just hitting play on a recording.
Yeah.
You're actually rewriting it a little bit, influenced by new info, or even just the act of remembering itself. It's more like a living document.
A living document.
Yeah,
Wow, and certain things can really mess with that document, right? Like the stress of the event itself.
definitely. High stress can really distort perception. Or think about weapon focus.
Oh, right, where the weapon just draws all your attention.
Exactly. You focus so much on the weapon that you miss other crucial details about the person holding it or the surroundings.
Okay, so stress, weapon focus, what else?
Well, just how long you actually saw the event, often it's incredibly short.
Makes sense.
The passage of time itself degrades memory, and then there are external influences, maybe media coverage, or even leading questions from investigators later on. Put all that together, and you've got a real potential for inaccuracy.
Which raises a huge question. If it's so potentially flawed, why is it still such a powerful force in the courtroom?
Well, like you said, it feels convincing, it connects.
But the real-world impact, it's severe. The unreliability of eyewitness accounts has, unfortunately, led to so many wrongful convictions.
It's truly sobering. Many of those have only been overturned later because of definitive DNA evidence.
Which is why the legal system is starting to look at it much more closely now, right?
Yes, increasingly. Modern legal systems often require corroboration, some kind of objective evidence to back up the eyewitness account. That shift is vital for justice.
Okay, so if human memory is this treacherous terrain, where do we find solid ground?
And that brings us squarely to physical evidence. That's where you get the objective, tangible link. Often it's irrefutable, connecting the suspect, the victim, and the crime scene.
This is where Locard's principle comes in.
Exactly. Locard's exchange principle, it's the bedrock concept. Every contact leaves a trace.
Simple idea, but profound.
It is, but the really fascinating part isn't just the idea itself, but the meticulous technique scientists use to actually find those tiny traces. A single fiber, a speck of dust, something that can totally change a case.
It's this idea that nothing just disappears without leaving some kind of mark.
Precisely, and that's why scientific methods are so valued in court. They are objective, they are repeatable, and crucially, they're verifiable. You can test them again.
Which leads to evidence with really high probative value, like DNA.
Oh, absolutely. A DNA match. The statistical probability of a random match can be minuscule, like 1 in a quadrillion, 10 to the power of 15. It's incredibly powerful evidence.
In fingerprints too, right? Based on uniqueness and permanence.
Yes. Fingerprint identification, when done by a trained expert, has exceptionally high value. Then you've got things like ballistics, matching bullets to guns.
Tool mark identification.
Yes, and toxicology reports finding drugs or poisons. These all provide objective findings that carry enormous weight.
They really bring a level of certainty that human perception just
It moves beyond guesswork.
But, okay, finding the evidence is one thing. Assessing its true value in the context of the case, that seems like the next big challenge.
You've hit on a key point. The value isn't inherent in the object itself. It's all about the context. A seemingly tiny piece can become pivotal.
How does that work? How do they link it?
Well, the crucial step is linking that exhibit, that piece of evidence, to a specific fact that's in question in the crime. So, take a single fiber, maybe from a common carpet, by itself, low value.
Right, could be from anywhere.
But let's say that fiber is identified as a rare type, and it matches the victim's specific jacket, and it's found on the suspect's clothing.
Ah, okay. Now it's different.
Suddenly, its value skyrockets. That tiny fiber tells a compelling story. It creates a link.
That makes sense. And speaking of uncovering things,
Yeah.
what about restoring serial numbers? Like on guns or cars when someone tries to grind them off? Is that information gone forever?
It often seems like it should be, but forensic science has a way. It's a fantastic example of ingenuity.
How do they do it?
Well, when numbers are stamped into metal, it's not just on the surface. It physically compresses the metal's crystal structure underneath. So, even if you grind the surface smooth, that compressed structure remains deeper down. Scientists use chemical etching. They apply reagents that dissolve the less compressed, surrounding metal faster than the compressed areas where the numbers were.
Wow. So the numbers reappear.
Gradually, yes, the original number is revealed. And successfully restoring that number provides a direct, high-value link maybe to the original owner or the item's history. It's almost poetic, science revealing what someone tried to erase.
That is remarkable. Even when someone tries to erase the past, the physical world remembers. So, okay, let's look at other specific exhibits. Footprints.
Footprints or footwear impressions are usually analyzed in two steps. First, class characteristics.
Like the brand, the size.
Exactly. Brand, size, the general tread pattern. That links the print to a group of similar shoes, but then they look for individual characteristics.
What are those?
Unique wear patterns, specific cuts, nicks, maybe a stone stuck in the tread, things that make that specific shoe unique.
So you could potentially link it directly to one shoe and therefore one person.
Potentially, yes. It can establish a very strong, definitive link.
And clothing. You mentioned it's like a repository of trace evidence.
Absolutely. Think about it. Clothes pick up everything.
Yeah.
Fibers, hair, soil particles, glass fragments, paint chips.
Bodily fluids, too, I suppose.
Yes, potentially. Analyzing all that trace material can directly link a suspect to a crime scene, or maybe link a suspect to a victim. Plus, the clothing itself might have pattern evidence, like bloodstain patterns or bullet holes, which can help reconstruct what actually happened.
Even something really common like copper wire, if it's stolen or involved in a fire.
Even copper wire can tell a story. Tool marks are key here. If the wire was cut, say, with bolt cutters or pliers.
The tool leaves its own fingerprint.
Essentially, yes.
Yeah.
That falls under tool mark analysis. The unique striations and marks left by the cutting tool can often be matched back to that specific tool if it's recovered. Another unique identifier.
Okay. And pieces of wood, like from a broken baseball bat or maybe a door frame.
That involves something called fracture matching. It's pretty straightforward conceptually.
Like a jigsaw puzzle.
Exactly like a jigsaw puzzle. You take the unique break or splinter pattern on one piece and see if it perfectly matches the pattern on its corresponding piece. Finding that physical match provides a direct, undeniable link between the two pieces, showing they were once joined. It tells a story of force, of impact.
So we've covered some really solid, reliable scientific methods.
Yeah.
But what about the newer stuff, the techniques that sometimes promise quick answers, but face a lot more debate?
Right, the cutting edge. Where science is still developing and the legal system is cautious. The polygraph, the lie detector, is a classic example.
Everyone knows the polygraph. But what's the actual science, or lack thereof?
Well, it's crucial to understand what it actually measures. It records physiological responses, heart rate, blood pressure, perspiration, breathing.
Okay.
The theory is that lying causes stress, which causes these physiological changes. But here's the critical scientific flaw. It doesn't directly detect lies.
It detects stress.
It detects physiological arousal or stress, which, yes, can be associated with deception, but it can also be caused by nervousness, fear, surprise, even if you're telling the absolute truth.
So someone could fail just by being anxious about the test itself.
Precisely. There's no scientifically proven unique physiological response that equates only to lying. And because of that fundamental lack of reliability and validation,
It's generally not admissible in court. at least not in the U.S.
Correct. Now, moving on to things like narcoanalysis or hypnotism.
The truth serums and putting people under hypnosis sounds very cinematic.
It does. The idea is you administer something like sodium pentothal or induce a hypnotic state to lower inhibitions, supposedly making the person unable to lie.
But does it work? What's the scientific reason these aren't really used in court?
They're highly unreliable, fundamentally so. Subjects under these influences can still lie, consciously or unconsciously.
Really? Even with a truth serum?
Yes. And worse, these states can actually lead to confabulation,
Confabulation.
creating false memories. The person might genuinely believe these false memories are true, but they aren't based in reality. They're constructed under suggestion or the influence of the drug or state.
So not only might they lie, they might invent things they believe are true.
Exactly, which makes the information obtained completely unreliable for legal purposes. It's just not admissible as evidence.
Okay, then there's brain mapping. Specifically something called BEOS, Brain Electrical Oscillation Signature Profiling. That sounds incredibly futuristic.
It is quite advanced. It involves measuring specific brainwave patterns, particularly something called the P300 component.
How does that relate to crime?
The technique presents the subject with crime-related words or images, maybe details only the perpetrator would know. The theory is that a guilty person's brain, upon recognizing these specific familiar details,
Will show a unique electrical signature, a recognition signal.
That's the theory. It attempts to detect guilty knowledge reflected in brain activity, specifically that P300 wave.
So where does BEOS stand legally? Is it being used?
It's complicated. While the technology is interesting, its reliability is still very much debated within the scientific community. There isn't full consensus yet.
So largely inadmissible.
Largely inadmissible in court, yes. New scientific evidence, especially something this complex, has to meet rigorous standards, like the Doebert standard in the U.S.
Which requires what?
It demands that the scientific evidence be based on scientifically valid methodology, that it's been tested, peer-reviewed, has a known error rate, and is generally accepted in the relevant scientific community. And of course, it has to be relevant to the case. BEOS isn't quite there yet on general acceptance and proven reliability.
So it's an area where science is definitely still evolving, and the law is, understandably, proceeding with caution.
Absolutely. You need that rigorous validation before something potentially life-altering is admitted as evidence.
Okay, so wrapping this all up, what's the big takeaway here? We've gone from the fallibility of human perception, that tricky eyewitness testimony,
that treacherous terrain,
all the way to the power of objective scientific physical evidence. Things like DNA, fingerprints, even that restored serial number.
Yeah, the things that provide those undeniable links that memory often just can't. Whether it's a giant match like DNA or a tiny fiber analyzed correctly.
And this deep dive really underscores how forensic science keeps evolving, doesn't it? And how vital rigorous testing and critical thinking are, especially when these new technologies pop up.
It's absolutely critical. The whole pursuit of truth within the justice system relies on being able to separate what's truly objective from, well, everything else.
Which leaves us, and you, with a final thought to maybe chew on, knowing how easily our own memories can sometimes mislead us. How much do you really rely on what you think you saw or heard versus what can be objectively measured or proven? And what does that distinction mean for how you understand truth, even, way outside the courtroom?